Hello, we are Group 13 and we'll be talking about the different forces that cause the fluid motion in the ocean. Surface ocean currents, which occur on the open ocean, are driven by a complex global wind system. Because the Earth rotates, circulating air is deflected. Instead of circulating in a straight pattern, the air deflects toward the right in the northern hemisphere and toward the left in the southern hemisphere, resulting in curved paths. This deflection is called the Coriolis effect. Global winds drag on the water's surface, causing it to move and build up in the direction that the wind is blowing. And just as the Coriolis effect deflects winds to the right in the northern hemisphere and to the left in the southern hemisphere, it also results in deflection of major surface ocean currents to the right in the northern hemisphere in a clockwise spiral, and to the left in the southern hemisphere in a counterclockwise spiral. These major spirals of ocean circling currents are called gyres and occur north and south of the equator. They do not occur at the equator, where the Coriolis effect is not present. Another force is geostrophic currents, which are a result of a balance of the Coriolis force and the pressure gradient force. When these two forces are equal, a horizontal flow is made, and it is called a geostrophic current. The current moves horizontally along the isobars. In the northern hemisphere, the high pressure flows to the right, and in the southern hemisphere, the high pressure flows to the left. This force occurs between the surface and Ekman layers. The velocity of the current can be taken from this force. By multiplying the difference of gravity in the Coriolis parameter by the pressure gradient, we can obtain the velocity of the current. The direction of the current is perpendicular to the slope, and as you can see from the pictures, the larger the slope, the stronger the current will be.
So another reason for the ocean circulation is the thermohaline circulation, which depends on the difference in temperature and salinity, which in turn determine the density of the seawater, and as a result determine the flow of the ocean. For example, as the salinity increases and temperature decreases for a fluid, the density for that fluid will increase, and consequently the lighter water masses float over denser ones, which is also known as stable stratification. Density reaches maximum value at 4 degrees Celsius for freshwater, but it can reach temperatures lower than that depending on the salt content in the seawater. Due to the higher temperatures and lower salt content around the equator, it tends to have lower density and migrates toward the poles. Overall, we introduced 3 reasons behind ocean circulation. They are Coriolis effect, geostrophic current, and thermohaline circulation. Thank you.